Hey everyone, today we're gonna be doing a lead code question which is to find length of a longest subarray having a frequency at max k for a particular character or number. So we are given some integer array num and a number k which will be denoting the maximum frequency a character can have or element can have. So they are saying they are saying the frequency of a number element can occur at most k times at most. So it can have at most n number of time, but we need to find a subarray having the frequency at most k times. Like it can be less than or equals to k, but we need something. You can say if this is a subarray, if I say till here frequency of 1 is 1, 2 is 1, here 2, 1 is 1, 1. So until here, all the frequency of a number, you can say there is three unique character 1, 2, and 3 having a frequency of each of them is 2. So they are saying a frequency, if a array, you can say subarray is a good subarray if the frequency of each character having at most k. The frequency of each character in a subarray having frequency less than equals to k will be a good subarray. So we need to find what is the maximum size of a, you can say maximum length of a subarray having that satisfying that good subarray condition, like having the frequency of each character less than equals to k. So they say like array is a continuous part. So yeah, I know we know like we need something sequential or a continuous part to create a subarray. Let's see the constraint. Like there are some example, like if for this case if a window size, or you can say like frequency for particular character can have at most one, so this will be our window for a case like for this two element, you can say in this subarray both the character, or you can say element having frequencies of one. So if you see this two can have, that two can have, so element having one frequency in a subarray will be a good subarray, and we need to return the maximum length there for that particular subarray. Same in this case, they are given 5555 as a number. They are saying element can have at most k frequency. We can say k occurrences. So I'll say, okay, I'll take this part having k occurrences. So now my size will become like what? 4, because I have taken this subarray. Similarly, I can take any of the subarray which is creating the frequency of a particular character as 4, at max 4. So I need to find all the subarray having the character of each, you can say frequency of each element at max k. So let's see the constraint. They are saying element can have at most, you can say minimum one element to 10 to the power 5 element in an array. The size of array, you can say. The number inside that array can range from 1 to 10 to the power 5, 10 to the power 9, which is very huge. And same, the k can go till 1 to the size of a array. So if I say, if I at max what k can have, so it can go till size of array, like number, if it is repeating, you can say in this character 5 is repeating 7 times. So in the constant they are saying k can go at max from 1 to 7. They can ask like, okay, tell me a subarray where k is 7. You can say a number can occur 7 times, so this will be our complete subarray. So they are saying, okay, k can go from 1 to size of a array. So let's see how to do this question with some example. We'll take the first example itself. So this is my first example, number array. Something is like 1, 2, 3, 1, 2, 3, and 1 and 2. So this is a you can say a complete array. We are given some character element, I can say some integer k, which is denoting the maximum occurrences of that number. For this example, like the first example, they are given this is a array, and this element, you can say this frequency can have each element in a subarray. We need to find what all subarray in this having the frequency k at max. So if I say, okay, this can be a subarray having frequency 1, this can be a subarray having frequency 1, this can be a subarray, like if I say consider this complete, each element having frequency 1. If I consider this subarray, the frequency of 1 become 2, which is okay because we are saying less than equals to k we can get. So I'll take, okay, I can include this part. I can include this part as well because 2 is coming twice only. I can have at most 2. Okay, I can include this as well because the frequency of 1, 2 and 2 is coming twice in this subarray. So now the size becomes 6. Like each element, if I say this particular alone, the size was 1. If I take this, size was 2. If I take this one, size was 3. If I take, you can say, if I take this particular complete, size was 6. But if I include this particular subarray, like if I include this element, Now it is coming thrice. You can say three times, which is like more than k, which cannot be a part of an array. So I can say the maximum size can be this of a subarray, which is a good subarray having character less than or equals to, you can say x. You can say x is a frequency of a particular element having less than equals to k in a subarray. So let's see, like if I say a very brute force approach, what we can do, we can generate, if I say approach one, this is my approach one, generate all subarray, generate all subarrays. So if I say the formula, how can, like how many subarrays can have using this particular array? So if I say this will be some size, so I can do like n into n plus 1 by 2. So this will tell me how many total subarrays can be generated. So you can see if my range they are saying can go from 10 to the power 5. If I generate all the subarray, it can at max I'll say if I'll take the n square part as a maximum part, dominant part. So I can say okay 10 to the power 10. You can say if I have n square operations, n can be equals to 10 to the power 5. So my n, like if I say my complete logic, it will be generating 10 to the power 10, you can say subarray. So for iterating and saving that subarray, my time, if I say my time and space complexity, okay? So my time space complexity will be n square each, because we will be iterating over the array and we will be storing that subarray. If I take a small example, suppose this is my subarray having 1, 2, 2, 2 and 1, and they are saying one can go at most 2. I can have 1 as my subarray. If I start from here, 1, 1, 1, 1, 1 and 2, 1, 1, 2 and 1. So if I start from here, I can have this as a subarray, I can have this as a subarray, I can have this as a subarray, I can have this complete as a subarray. If I start from here, I can have this one, I can have this one, I can have this one. So if I start from the another one, I can have 1, 1, 1, 2, 1, 2, 1. If I start from here, I can have at max what? 1, start from 2, sorry. So 2 I'll start, I'll have 2, 1. If I start from here, I can have only 1. So you can see these many subarrays generated using this particular array. And if you see the frequency for each, this is having frequency 1 of 1. Here one frequency is 2. Here one frequency is 2 and 2 frequency is 1. Like how many times this is occurred in this array. So 1 occur 2 times and 2 occur 1 time. So if I say okay, now for this particular array 1 occur 3 time and 2 occur 1 time. So this is not a valid part, like they are saying a frequency of a particular character can go at max. What at max can go? It can go at max 2 here, a k time. But for this, it is going 3 times. So this is not a valid subarray. I'll say this is not a valid subarray. I'll mark this one. Okay, this is not a valid subarray. So what I need to do? I need to iterate over this, and then I need to find if the element is satisfying this particular condition or not. And I need to store the length of a maximum subarray. So for this example, 1, 1 and 2, it is a maximum subarray having the frequency at max k for any of the element. So for this, having 1 frequency is 2, 2 frequency is 1. So this can be a subarray, this can be a subarray. Here, this all can be subarray. We need to find the maximum length. So if I say these two length, say 3 is the maximum length of a subarray, which can be a part of this equation. But if I generate all the subarray for this example, this will be huge. So what I'll do, I need to optimize somewhat. So for from n square, I can come to n log n or n. So what I'll do, I'll use something called two pointers approach. What I will be maintaining, I will be maintaining my window size. For if you see, we have a window starting from here. I included this, I included this, I included this. What we are doing, we are starting from here. We are just keep on including the element. So we are increasing the size of a window. In again, what we do, we decrease the size of a previous window like this. If I started from here, if I started from here, my window size decreased. If I start from here, my window size will again decrease. So what I will be maintaining, I will be maintaining two pointers. Starting from here, it will be like, firstly, it will be increasing all the size, then it will be reducing the size. But it will be done in a single for loop. So what I will be doing, like if I say my approach to, it will be like something you can say 2 pointers, and I will be using somewhat concept of a sliding window. So this is like somewhat same question. If nobody have, like any of you have not done the yesterday's question, go and check out. I will ping my video in the I box. So it's like the same concept we use there. Like we will be using some 2 pointers to storing and finding the frequency. So I got one thing for getting the frequency. I need something called counter or frequency counter or a hash map or hash set. So I will be maintaining a hash set. So if I say, if I have a array, this is our array 1, 2, 3, 1, 2, 3, 1 and 2, the first one. K is given 2 in this case. If I say, okay, let's create, I can have a starting point of a left, right, okay. I can have a starting point of a left and right. I will be denoting the size for that particular window. I will be having the frequency of that particular window. Okay, so if I start from this character, suppose this is a starting position like index of 0, 1, 2, 3, 4, 5, 6, and 7. What I need to do, I need to have something like size. I need to define the size. Initially, I can start from 0, 0. It will be having this particular as a size. So my first size is 1 because I'm starting from 0 to 0, and the frequency of 1 become 1 in this case. So I got a maximum length as a 1 in initial case. If I shift my right pointer, if I say this is something I will be shifting each time, and I have something called left and right pointer. What I will be doing, I will be incrementing my right each time. I will be including this, I will be like creating a window for this example. So if I include the right in my window, now my left is at 0, my right came to 1, the size become 2, the frequency of 1 become 1 and 2 also become 1. Okay, if I include the 3 again, I'm just shifting my window. I included the second index value, my size became 3. My initial, I can say the frequency of all the elements in that particular window is like incremented once. Okay, for this it is coming once, 2 is coming once, 3 is coming once. I will be like shifting my window until it is satisfying the condition. Okay. So each time when I append this value, I will check, is it okay? It is less than equals to k. Okay, it's fine. You can go ahead. So I'll say, okay, go ahead. I'll have 3. My right pointer shifted to second index at first go. Again shifted to third index. So again, I'll include what? I'll include 1 in this case. My size become 1, a 4. My window, or you can say my value of a 2 increased to my value for the 1 index. You can say I included a third index. Third index, the value is 1. If I say the value, the element, I'll say this is my element. At here, it was 1, 2, 3, and again it came 1. So if I write all these number, it will come 2 again, 3 again, 1 come, and 2 come. Okay. This is our elements at that particular window. If I say, if I'm including my right, each time I will be appending my right. So it will be like coming to 4. This will be increasing all time. It will be coming to 5, it will be coming to 6, it will be coming to 7. This is my default behavior. I need to shift my right pointer as far as I'm including that particular character or the element. This is my fix because I will be like adding that particular element in my frequency hash map. So here I included 1 again. This I included 1 again. My window become like this. The frequency of 1 become 2. 2 is 1 and 3 is also 1. Okay, next time what I'll do, I'll again my initial window, you can say 0 is still here. I'll include my fourth character which is 2. Size become 5. 1 is coming twice. We include 2 here again. So for this window, 1 and 2 is coming twice. 3 is coming only once. Okay, this is also fine. We can have this. We'll again move on. I'll shift my right pointer. Like I'm just shifting my right pointer right and right. Just I'll append each of the character, the element in my frequency map until it is satisfying that k less than, you can say, the frequency of that right element less than k. So what I'll do, I'll again include this third value, or you can say fifth value, I just shifted to right pointer, it came to 3. I'll say okay, it is also starting from 0th index, size becomes 6. My frequency of 1 is 2, 2 is also 2, now 3 is also 2 because we included all these starting from 0 to 5, size becomes 6. Okay, so now if you see, it is also fine. Now again I'll shift my right pointer to next. It will come to 6th index. Now it will be having size as 7. It is starting from 0. But now if you see, if I include 1 again, the frequency of a 1 will be 3, 2 will be 2 and 3 will be 2. If you see, the frequency of the added element increase the kth limit. So it increased the kth limit. What I need to do? I need to remove 1 from in this example. So I need to remove all the element until my frequency of a current element. If you see, the one's element is 3. I need to remove all the element till it increases decreases the value of a 1, or you can say frequency of a 1, 2 or less. You can say you need to decrement somewhat less than k. Here it came 3. I need to came down to less than or equals to k. I will be decrementing, or you can say I will be removing all the elements from the right until it become less. So if I decrement this value, if I remove this case, and this is my window, we'll say my window again at 6th, and that particular index I shifted like left value, I shifted this left to 1 next, which will be like removing this first index. It is not sure like every time we have that particular index at the first, it can be anything. So we need to remove all of them till our frequency of a 1 reduces to less than or equals to k. So I will be like removing that particular number. So for index 1, like index 0 I removed, my starting point is now at 1. So if I remove the first value, if I say I remove the first value here at index 0, because it was the left pointer, I just shifted my left pointer, it became 1 now. The size becomes 6 and the frequency become what? 2 again of all of them. Again, if it is satisfying, I will be moving to the next element. So again, what I will be doing, I will be adding the twos element, you can say, in this next window. I will be shifting this window to right. This we included at previous case. So here the window size become this much, but we have 3 ones coming here. So what I need to do, I need to remove the previous one till this window having all the frequency at max k. So I initially I was having this size, I just remove this size. Now my new window become like this. I'll again add this window, next element to the window. Now the 2 coming twice. I need to remove any of 1 2's from here. So I'll remove, or you can say decrement, or you can say reduce my window size. So coming from this window, if I say starting, the element is 2 at index 1, at index 1, and it is going till size r, you can say it is going here. So okay, I'll say okay, now my window size is again 7. The frequency of 1 is 2, but in this case 2's frequency increased to 3 and 3 is 2. Okay, so again this is not satisfying my condition. I need to remove any one, or you can say any 2 from this list. So I will be like shifting my left until I will be shifting this left until I remove any one of the 2, which reduces the frequency. So again, I need to remove this 2 from my case. So I'll say this is my 2. I need to remove this element. If I remove this element, my left is point shifted to right. You can say my left shifted to next. So the size become here what? A starting point become 2, ending point you can say left is now at 2, right is now at 7, the size becomes 6 again. The frequency become 2, one's frequency is 2, two's frequency also 2, and three is also frequency 2, because what happened? If I included previously I have this frequency, I have included this in my window. My window having frequency of 2 become 3. I need to remove one of them. So if I remove the element one by one till this become less than equals to k. So in my previous like initial go only, like in the first go, this if I remove this one, if I shifted my right, I left to right, I remove this element, my frequency again become 2 for each of them. So what I am just doing, I am just including all the right if my increasing the frequency, and I am removing all the left pointer to decrease my frequency. So let's see how to do this with the example of a code. So I'll simply write a code here. I'll increase the font. Okay. So what I need to do, I need to maintain some left and right pointer. I have right and left pointer starting from 0. I will be having size of a that array. So this is the size of array. I will be storing the frequency, having like something called frequency map. I will be using a dictionary here. So instead of using normal dictionary, I will be using default dictionary, which will be like storing default values of 1 if something is not found. So I will be having default default found dictionary having integer as a value. What it will be doing, like suppose if any of the element comes first time, it will be storing 1 as their value. So it will not throw any error if that particular key is not found in the you can say that hash map, or you can say dictionary. What I will be doing, I will be iterating from right to the size of an array. Okay, every time I will be like incrementing my right pointer. At last, I will be returning the max size, you can say max size, max length. This also we need to define because we will be storing size of a current window or the subarray having that frequency less than equals to k. So this is our skeleton. What I will be doing, like I need to add the frequency of the current incoming element. So what I will be doing, this is my frequency map. I will be storing the, like I will be incrementing the frequency of the incoming element. So the element at right index will be added each time. I'll say okay, increment its frequency to 1. And if something happens and this like the frequency of the included element, this element becomes greater than k, with greater than k, what I need to do, I need to remove the element from the left till it become less than equals to k. So what I'll do, I'll remove the frequency of a left pointer to 1 element. I will be like removing my left character from, you can say left element from the subarray. Every time it will be reducing the size, or you can say window of a current size. It will be like creating a fixed subarray satisfying all the condition. Each time we need to see the maximum length which is contributing using that subarray. So I will be saying okay, max length will be max length, or and now we need to find the size of a subarray. So what we can do, using the right index and the left, like if I say the boundary will be from left to right, if I say right minus left, it will be like giving me the size, like the elements in that. So if I say starting from 0 going to 0, it is giving me, like if I include the element 0, the index at element 0, you can say element at index 0 is like giving me size 1. So if I say okay, right minus left will be giving 0, so I need to add one more. If I say my left added 0, right came to 1, if I have this as my window, I have two elements. If I say right minus left, it will be 1 minus 0 will be 1, but I need to include one more to tell this will be the number of element in that subarray. So what I will be doing, I will be doing like this is my current window size, left minus right minus left plus 1. So this will be creating a window size for a particular subarray. So each time we will be storing the size of a current window until it is satisfying that condition something less than k. As far as it goes to max, like it goes at max k or more than k, we will be removing the element from the left. And for what? The element we included just now. So we just will see if this code is working fine or not. We'll compile this code. It is working fine. I'll submit this code just to see if complete code is working fine or not. So as I can see, yeah, it's completely fine and it's bit optimized. So yeah, that's all for today's. Thanks for watching.